Good morning, good afternoon, and or good evening to you geometry students. I'm going to get started right off the bat today. I really have nothing to say other than grades are updated in Harmony, and some of you are looking pretty sharp. We got 3 weeks of school left, everybody, so let's finish strong. Answers, of course, are at the top. Go ahead and check your answers. You are not turning in your homework other than through email to me, so you have all your homework assignments. I would check them along the way just to make sure that you're doing these problems right. All right. What do you say, everybody? What do you say we get started? 11.3. What do we got today? Hopefully a short lesson for you. I don't know. Area of circles and sectors. Area of circles and sectors. That's what Mr. Kosal's got for us this morning, afternoon, or evening. I wonder, are you a morning homework doer, an afternoon homework doer, or an evening homework doer? I don't know. Alright, let's get started, everybody. Area of circles. I think I've already introduced this equation to you back in chapter 10 when we did the circles chapter, because I gave it to you with circumference. So here's a good review for everybody. Go ahead and write the circumference equation down of a circle. Circumference equals pi times diameter. Once again, that is if you have a circle. If you wanted to walk the complete distance around the circle, if you were, let's say, I don't know, an insect, a ladybug, a spider, and you wanted to walk completely around the circle and stop at where you ended, that's called the circumference. You're traveling the distance around a circle. Area of a circle is, I like to think, one of the most famous equations in all of geometry. Area equals pi r squared. Area equals pi radius squared. So circumference, area, a little different, actually completely different. Area is if you fill the entire circle in with paint, with a colored pencil, with a marker. That's how much you can actually fit inside the circle. Area equals pi r squared. Wow, are we already ready for example 1? Here we go, folks. Example 1. I'd like you to find the radius of a circle with area of 58 inches squared. Find the radius of a circle with area of 58 inches squared. Alright, notice how we're trying to find the radius this time. I'm not just going to give you a radius, have you plug it in this equation, punch it in the calculator, find the area. I'm actually going backwards. I'm going to give you the area this time, and we're going to go ahead and find the radius. Go ahead and start by writing your area formula for a circle. Area equals pi r squared. And plug in the information that you know. We know, and we are given the area is 58, so that's going to go right here, folks. So 58. We can neglect the units for the time being. We know that the radius is, if the area is inches squared, I think the radius is going to be in inches. 7 inches, 54 inches, 13 inches. It's going to be in inches. So go ahead and disregard the units. Equals pi r squared. All right. How do we solve for the radius? Because if you're ever wondering what we're trying to find, just read the question. Find the radius. We're trying to find the radius. So this is what we're trying to find. And we know there's multiplication between the pi and the r squared. So go ahead and divide both sides by pi. So you divide both sides by pi. What that's going to do on the right-hand side is it's going to cancel those two pi's. So the r squared comes down, and you've got 58 divided by pi. Now I hope you have a calculator. If you don't have a calculator, find it. Pause the video, go get it. It's kind of important that you're punching this out with me. I've got my iPhone here, It is 7:02 at night, so I'm recording this video the night prior, just to stay ahead of the game, everybody. So let's go sideways. Okay, let's see. I want to do 58 divided by, where's my pi button? Pi equals. All right, so I'm getting r squared equals 18.46 dot 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 dot. I'm not going to write down every number. And I am going to keep this in my calculator because the very next thing I got to do to find the radius, can you guess it? Yep, square root. Square root both sides. So the square root of r squared is going to give you r equals, so where's my square root button on here? For you iPhone users, it's right there. It's right above the sign button, so hit that square root button, and it's going to be about, we can round this, about 4.3 inches. In the book, it's going to be very specific about rounding. It's going to say round your units to the nearest tenth, 4.3. It might even say round to the nearest hundredth. In that case, it'd be 4.30, because that 6 kicks the 9 up to a 10, kicks that 2 up to a 3. Make sure you have a unit in the hundredths place. All right, well, that was pretty simple. Example 2. Okay. Let's start with the picture, shall we? Draw a circle. Give it a center. And then I'd like you to draw a smaller circle inside of this circle with the exact same center. So for me, I'm just going to try to keep it equidistant from the outer edge. In essence, you're kind of making a target, making a bullseye, so to speak. Alright, here's your second circle. Let's give the radius of the inner circle as just 6. 6, I'm not going to give units, just 6. I'm going to say that this uniform edge from here to here is 2. And I would like you to find the area, not of this whole thing. I'd like you to find the area. Let's make this interesting, shall we? I'd like you to find the shaded area. So we're going to find the area in between these two circles. And I'll put some directions down. Find the shaded area. Okay. Now, going about this problem is actually sort of simple. It shouldn't be that difficult. You just need to have a game plan. You need to have the process understood before you get started. To find the area of just this little ring between the two circles, really in essence, you're going to find the area of the big circle. You are going to subtract the area of the little circle, which it's kind of hard to visualize. Some of you can visualize that with me. Getting the words out. But if you take the big circle and you minus the small circle, what you're going to have left with equals, make this an equation, is you're going to have the big circle minus the small circle's area. So that area is subtracted from that total area, and what you should have left is this little ring. That's the game plan, and that's the process. So let's go ahead and do that. So the area of the big circle is going to be pi r squared. The area of the small circle is, once again, pi r squared. They're both circles. And we need to subtract them. So pi r squared, so that's going to be pi radius of the big circle. Oh boy, we don't have that. Darn it. Minus pi radius of the small circle. We got that. It's 6. Now to find the radius of the big circle, it's not that difficult, folks. If the distance between the small circle and the big circle is 2, then you can also come down here and say that distance is also 2. So then the radius from the center to the outermost edge is going to be a grand total of 8. And that's the radius of the large circle. So let's go ahead and throw that in there. Okay, so what's that going to give us? It's big circle minus a small circle. That's going to give us our answer. So what is that? 64. That's 64 right there. So what is that? 64 pi minus, that's 6 times 6, 36. 36 pi. Now, you can punch this out as a decimal. You can punch that out as a decimal on your calculators. Subtract those decimals and you'll get the answers. Or, before I even jump to my calculator, I'm just going to subtract like terms. It's kind of like if you've got 64x minus 36x. You put these together, you know they're like terms, you're going to get 28x. Same thing here, 64 pi minus 36 pi is 28 pi. There's your answer, folks. So let me go ahead and punch that out in the calculator. 28 times pi. Pi button right there. Bam. There's your answer. That's the area. It's 87 point, let's go hundredths. Or you can do 88.0 or 88 units squared. If you want to go exact measurement, it's going to be 28 pi units squared. Either one of these answers is correct. This answer right here is what we call an exact answer. This answer right here is when you take this exact answer and you punch it in the calculator to get a decimal answer. 9 times out of 10, I think the book is going to ask for a decimal, and they're going to specify where to round it. Round to the nearest tenths, hundreds, thousands. You get the idea. All right, not bad. One more thing I want to do with you is I want to teach you what sectors are, because if you go back to the title, we just did areas of circles. We just kind of took care of that. Let's talk about sectors. So a sector, let me make a little squiggle. Go ahead and write down the word sector. A sector is another fancy word for a slice of pizza. So if you drew a circle and you gave your circle a center, and let's draw a slice of pizza. It's a big slice of pizza. And you shade that in. We're not going to shade the whole circle because that would be the area of the circle. And let's say I don't want to eat the whole area of the circle. I just want to eat this piece of pizza. That is what we call a sector of the circle. That's a sector, folks. Now there's an equation to find the area of this sector. And it looks like this. It's actually derived from area equals pi r squared. For a full circle, the area equation is pi r squared. But this is not a full circle. We're taking a fraction of the circle. So the sector equation is going to look like this. It's going to be x over 360 times pi r squared. That is the area equation for a sector. Notice how these look very, very similar. I'm not going to draw that circle again. I could just come up here. The only difference is, see, look at that, look at that. Pi r squared, pi r squared. The only difference is you've got an x over 360. Now the question is, what is that x right there? The x is this angle measure right here. That is really hard to see. The x is the angle measure of this angle. And now it's over 360 degrees because you're taking a partial fraction of a whole. 360 is a whole circle. And we're going to take an angle measure out of a whole circle. This is your sector area equation. All right. Example 3.